For the next part of our lesson, we're going to talk about the end behavior of a function. The end behavior of a function, we use the word limits. Okay, so your graphs will either be approaching positive infinity or negative infinity. And those are the only two answers that we're going to have from here on out when we're talking about a limit. So we would represent this, we would say that we have the limit of f of x as x approaches negative infinity. This is always going to be the left side of your graph. Now, every time that we talk about the leading coefficient, and we're trying to figure out if the leading coefficient is positive or negative, we're talking about the right side of our graph. So we have the limit of f of x as x approaches positive infinity, and that's the right side of my graph. And that's also always talking about that leading coefficient. So are we going up or are we going down? So in this first problem, we have f of x, and we have the limit of f of x as x approaches negative infinity, which is going to be the left side of my graph. Now, on the left side of my graph, I could put a downward arrow right there. So since I have a downward arrow, we would say negative infinity. We have the limit of f of x as x approaches positive infinity. So as x continues this way, what happens to the graph? Well, all the x values will keep going towards positive infinity. And the next one, we have g of x. So I'm going to talk about the left side of my graph. So the left side of my graph, we can go ahead and say positive infinity because it's going an up arrow. The right side of my graph, I can put a downward arrow, meaning it's going towards negative infinity. Now, these are like the heights of the graph, it's the end behavior, where it's going. In the first graph of f of x, remember when we're talking about leading coefficient, what would my leading coefficient be in this graph of f of x? If you're thinking positive, you're correct. Okay, the leading coefficient has to be positive because it's going in the up direction. And the next one, my leading coefficient would have to be negative because it's going in the downward direction for g of x. And the next one, the left side of my graph, we have negative infinity. On the right side of my graph, it's going downwards towards negative infinity. So again, my leading coefficient, we're looking at the right side of my graph, it's going downwards, so my leading coefficient would have to be negative. Go ahead and try to determine the end behavior of these three functions. So for b of x, the limit of b of x as x approaches negative infinity, we have an up arrow, so we have positive infinity, and the limit of b of x as x approaches positive infinity, we have another up arrow, which is positive infinity. For the limit of c of x as x approaches negative infinity, we have positive infinity. Limit of c of x as x approaches positive infinity, we're going towards negative infinity. So my leading coefficient for b of x would be positive. My leading coefficient for c of x would be negative. And finally, we have d of x. So the limit of d of x as x approaches negative infinity, we have negative infinity. And the limit of d of x as x approaches positive infinity is positive infinity. My leading coefficient would be positive here. So for each of our graphs below, we were able to either write positive or negative infinity. So that's always your answer when we're talking about the limit of something in relation to our polynomial functions. So the end behavior is determined by two factors. So we have the signs of the leading coefficient. That's one of our factors, which is why we've been talking about it so much. And then we have the degree of the polynomial function. So degree also has a role in determining that end behavior. So right here for this number 1, we have our degree. And our degree is related to the 0. So I can say that the degree is 2. Now my leading coefficient, I can put an up arrow right there, which means that my leading coefficient is positive. Now the limit of b of x as x approaches negative infinity, so I can put an up arrow over here, which means that it's approaching positive infinity. And the limit of b of x as x approaches positive infinity, we already have that up arrow right there. It is positive infinity. For number 2, we're going to start by putting points on the zeros, which relates to the degree. So the degree of this polynomial is 2. Now the leading coefficient is based on the end. So on the right-hand side, it's going down, which means that my leading coefficient is negative. For this problem, the limit of c of x as x approaches negative infinity, we have another down arrow, so we have negative infinity. Limit of c of x as x approaches positive infinity, we also have negative infinity. Now check these out. My degree was 2. They were both even, and the limit for both of them, the end behavior for both of them was the same. Let's see if that's true for number 3 and 4. So for number 3, my degree is 1, 2, 3 zeros, which makes my degree 3. The leading coefficient, I have an up arrow on the end, which makes that my leading coefficient is positive. Limit of d of x as x approaches negative infinity is going to be negative infinity. And limit of d of x as x approaches positive infinity, we already have that up arrow, and it's positive infinity. So degree was odd, and we were starting and ending in 2 opposite directions, and that did have an effect on the end behavior. They were opposite of one another. Let's see if that's true for number 4. This one also has an odd degree, and the degree is 3. Now this problem, my leading coefficient is negative because it's going in the downward direction. The limit of f of x as x approaches negative infinity is going towards positive infinity. Right here, I could put an up arrow at the very beginning. The limit of f of x as x approaches infinity is actually going towards negative infinity. That's my end behavior. So the degree is 3 for both of these, 3 and 4, and we had opposite end behaviors. One was negative infinity and one was positive infinity. Go ahead and try numbers 5 and 6. For numbers 5 and 6, they both had even degrees, which ironically enough, the end behaviors were either both positive infinity or both negative infinity. And then for my leading coefficient, when the leading coefficient was positive, we had an end behavior that was positive, and when my leading coefficient was negative, we had an end behavior that was negative. Now this all relates when we're not looking at graphs. It all relates to even when we're looking at, I'm going to skip over that, when we're looking at just the function. So we're always going to start with the right-hand side. This is where my leading coefficient comes into play. Now, depending on if the degree is even, if the degree is an even number, then they're going to be the same. If the degree is odd, then they're going to be opposite of one another. So for number 7, my function of f of x, we're going to start by writing down the degree. And the degree, remember, it has to be in standard form. So check and see if it's in standard form. And the highest degree is 5. My leading coefficient is a negative 2. So off to the side, if I were to draw a graph of this function, we're just going to draw a rough graph. With the leading coefficient being negative, I'm going to put a down arrow right here. So that means that on the right side of my graph, we're at negative infinity. Now, because the degree was 5, we had an odd degree. They're going to be opposites of one another. So I can go ahead and write down positive infinity. For number 8, let's figure out what our degree is. So we have 1, 2, 3, 4. So my degree is 4, and my leading coefficient is actually negative 2. So if I were to draw a fake graph off to the side, my leading coefficient being negative means that we are in the downward direction, and so we can write down negative infinity. And the degree is 4, so we have an even degree. Right? Since it's an even degree, they're going to be exactly the same. So we have negative infinity. For number 9, my degree, the highest degree in standard form is 3. And my leading coefficient is a positive 4. So if we were to draw a rough graph over here, the leading coefficient is a positive number, so we have up. And the degree is 3, which is an odd number. So we have positive infinity on the right-hand side, but on the left-hand side, since it's odd, it's going to be opposite. So we have opposite of positive is going to be negative infinity. And number 10, we have 1, 2, 3, 4, 5. My degree is 5. My leading coefficient is that very first number. My leading coefficient is a positive 5. So if we were to draw a rough graph over here, I would put an up arrow. So we have positive infinity. Now the degree is 5, which makes it odd. And since it's odd, they're going to be opposites. We have negative infinity. So we're always filling in the right-hand side first. And number 11, my degree is 6. My leading coefficient is negative 3. So off to the side, if we were to draw a rough graph, we would have a downward arrow, which means negative infinity. Now because the degree is 6 and it's an even number, they're going to be exactly the same. So we have negative infinity too. And then finally, number 12, we have 1, 2, 3, 4. So my degree is 4. My leading coefficient would be 1x to the power of 4. So my leading coefficient is 1. So on my graph over here, my leading coefficient is a positive number, so it'd be up. So we have positive infinity. The degree is 4, it's even. So they're going to be exactly the same, which makes it positive infinity. So for all of these, we're evaluating limits, and those limits are talking about the end behavior. Your answer is going to be either positive infinity or negative infinity throughout this unit.